I'm just I'm taking Zara's assignment. Give me a minute. Let me. Yeah. Can you please enable the sharing, please?
Done, sir.
Thank you very much. Guys, are you able to see my screen?
Yes, sir.
Great, thank you. So, it's very much interesting. The analogy for the waterfall model you guys have come up with. Do you have any questions, out of this forum? Do you have any questions about the steps, what has been defined in the this model? You didn't understand something? We will go through in anyways of the whole steps, okay? But before I jump in, do you guys have any doubts, okay, so far with respect to this waterfall model? It's a time to ask the question before we jump in, okay? If I don't hear, let's move on then. So as we discussed, okay, we follow different methodologies to build anything. Last time we were talking about manufacturing plates.
Let's.
With the planning, mold, and then polishing, distribution, and all those things, right? Lot of phases we discussed. It's the same thing. The same methodologies actually been followed in building the software or anything for that matter. In conjunction with our software development, okay, we use one of the most used the development model is the waterfall model. So in this we have a couple of phases, right? We have requirements, we have design, we have development, we have testing, we have deployment, and then we have maintenance. Let's go one by one. Can anyone tell me what is requirements?
It's a need of the customer.
Need of the customer. Very well done. Any other? That's really a good pointer, I must say. So who is the end customer here? Either it can be you or it can be somebody else. What is required by the customer? Right? So
Yes.
let's go back to our previous example, what we were discussing in the last week. The requirement was to manufacture a plate.
Yes.
Or can be metal plate, right? Now, under that metal plate, they give you another requirement. I need a certain design. I need a print. Something. It's all comes under the requirement, isn't it? So they have mentioned they need a metal plate. They need a design pattern, some lion or whatever. Okay, should be printed on that, and it should be it should be having a round edges. So these are all requirements. Correct?
Yes, sir.
They've not, just that's the requirement. You have to have a round plate, round edge plate, and I need to have a print, and in between that, okay, and it should be a metal plate. So see, it's a specific requirement. It should be a metal plate, right? And then comes, they will say, okay, that plate, I should, at least I can accommodate a volume of quarter liter. It's a big plate, okay? Then or 100 ml or 200 ml, whatever. If I fill something into that, it should be I should have volume of 200 ml. So these are all the requirements. It's an end user requirements. When you go to the shop to buy a plate, don't you see a different plates altogether? And then you choose which one to pick to your according to your needs, correct?
Yes, sir.
So that is your requirements. Likewise, in order to manufacture the plates, those are the requirements from the end user perspective. Now comes, so you got the requirements from the customer. Now you as a manufacturer, let's take an example. We are manufacturing. Now you take those requirements, you design them. So how you'll come up with the different shapes or different sizes. You see, the requirement was to accommodate 200 ml of volume, correct? It can be small plate with lot of depth. So definitely it can accommodate 200 ml quantity, correct? Or it should be a bigger plate, okay? And then the whole the whole radius will can accommodate the area can accommodate 200 ml, okay? And there is to be print, okay? You come up with the design, you go to the client, look, these are my designs. What kind of is my understanding right? Is that what you wanted? Correct. You come up with the blueprints of of those the plates, round plates, thin plates, in depth plates, whatever it is, okay? You come up with your designs, you present to the client, and they will say, okay, look, I'm looking for the bigger plate, okay, with the round edges, and which can can accommodate 200 ml volume. So now you got the confirmation from the client. This is the requirement they're looking for. So you follow that particular design now. So we have validated the requirements. According to the requirement, we have designed what is needed. And now comes, once the design is finalized, you go for the development or manufacturing. Correct? In our example, we the plate, so we manufacture it. How do we manufacture it? We will have mold. We'll take raw material. We melt it. We pour it into the molds for the same design what we have finalized. Okay, and then we manufacture that particular plate. Once that manufacturing is done, what do? You go and check. You will go and verify whether the plate what we manufactured is in accordance with respect to the design and the requirement. Correct? My requirement says a bigger a plate,
200.
less depth, and everything. Now I go back and in this phase, I go back and test or verify the plate which has been manufactured is in accordance with the design what is be agreed, and it is in line with the requirements what has been agreed with the client. This is a very crucial phase. I know every phase is a crucial thing, but at the same time, the testing is a very, very crucial phase as part of software development or any manufacturing, anything for that matter. If I make a plate which is not in line with the design and the requirement, if you start, distribute it, what will happen to the client? They are not happy. They will say, it's a rejected one. We can't take this. The moment they say rejected, what will happen? It's a loss to the manufacturer. When it's a loss, it can be financial, it can be anything. The time, the resource, the money, the reputation in the market, right? If you get a 40 phone of Samsung, 10 people, you will always, you will spread that word across to different people. Oh, this phone is really faulty. I can't use it. Don't buy it. What will actually happen? You will lose the market share. When you lose the market share, it will impact on your revenue. It will impact on your reputation in the market, isn't it? So testing is a very, very crucial phase in any software development or manufacturing. You name it, anything, any sector, if you take it up. Okay, once the testing is completed, and then what do? We deploy. When I, in the software terms, like, we deploy an application to use, for example, WhatsApp. Okay, we install that on a phone to use it, right? Likewise, in our, in accordance to example, the plate, the deployment, it can be like, distribution or usage, right? So people start using the plates, they're happy, or the customer is actually happy. And you also provide something like, called a maintenance. So if I take an example of your fridge, they will say for it's a 2-year, the fridge will come with a 2-year guarantee or a warranty. So any fault comes, we will come and fix it for free of cost. It is a maintenance, right? So they'll come and look after the fridge for 2 years without no cost. Likewise, it can be a plate, a very premium plate, what you have manufactured. If something goes wrong, okay, we will come and replace it. Something, in that sort. Are you guys with me?
Yes, sir.
Okay. So it's a step-based approach in terms of developing any software or manufacturing anything for that matter. So requirements is a very key thing. That is the need of a customer. The design, we, as a manufacturer or a developer, development company who, design the, the need of a customer, and they develop or manufacture it. They test it, and they deploy or for their usage or a client usage, and the maintenance. It's a very simple step-by-step approach, okay, of the development. So the advantage here in this particular model is that without you finalizing the requirement, you will not go to the design. So you have to have a concrete requirements, specific requirements by the client. And you as a manufacturer, you should understand those requirements. Now you come back and you design, okay, the requirements. So without completion of this particular design, you will not go to the development or manufacturing. Because what if you manufacture something, while you're designing, the patterns or the plate or, whatever you call it as, and later you realize that, the design is completely different than what actually you have started manufacturing. What actually happens? Loss of revenue, loss of time, correct? These are the risks. So until the development is actually completed, the testing will not be initiated or verification. In our case, manufacturing the plate, without manufacturing the plate, do you think you can test it? I don't think you can test it. So you perform the testing. What do we do as part of testing? We confirm the manufactured goods or the software which has been built is in line with the design and the requirements. Once the testing is completed, then you will go and deploy that particular application. Until then, you will not get into the deployment phase. What do you mean by deployment phase? Deployment phase. It is a production. Or the end user will be using it. Right? Let's take an example of fridge, right? That has been tested in the at the manufacturing side, and the custom we buy that particular fridge. So until the testing is completed, it will not be released to the to the clients or the customers or consumers, right? Once this has been done, that means it's already in the production. Now comes the maintenance to make sure the manufactured items or a developed software is functioning or working appropriately. If there are any faults, then go back and fix them. Make sense?
Yes, sir.
Yeah.
Okay.
Any doubts so far?
No, sir.
No, sir.
No, sir.
No? Okay, very good. It's the same thing what you guys actually have came up with. We did cover the requirements, we did cover the system design, we did cover the implementation, and then we have something called integration and testing, which is a very good thing what you have identified. Okay, what do you mean by integration? Any input on this? Any comments for anyone? What do you mean by integration?
Altogether,
Sorry?
altogether testing after unit wise, no, altogether.
What do you mean by all together? Precisely. Can you give me any example, specific example?
Not as a part, but as a whole.
As a whole, what do you, yeah, I'm looking even more precise answers. Take any example. Anyone else?
Sir, software is developed into many units. The units are together made together to make a system, one full software system.
Correct. Yeah. So you develop in the piece by piece. Let's take an example of a fridge, right? The motor is manufactured by someone or some division in that particular company. The doors manufactured by different division, and the glass panels, all this, toughened glasses, whatever you call it as, that has been manufactured by somebody else, right? Or some different division within the company. Now you are bringing all those components which was manufactured separately by different divisions, and you are actually bringing them together and assembling them each at one time. You bring the unit, you fix the motor, okay, and then you start fixing the compartments, the glass or whatever, okay, And what actually you're doing, you're integrating them together to make a whole system. What you have done is earlier, you have actually tested the motor on its own by a different division. The toughened glasses was tested by a manufacturer and tested by a different division on its own. Now, the doors or the compartments was manufactured by a different division and tested on its own. Now you're bringing all of them together, and now you are actually integrating one by one, motor and the structure or frame. Now you will check whether the motor can be fixed into that particular frame. If you could able to if it is the right size and it is able to fit into it, then you will say, okay, these two are working fine. Right? Now you bring in the compartments or the glasses. You will try to create the different compartment, different shapes and everything, whatever you have agreed in your design, right? Now, am I able to fit in all those compartments according to my design? So now actually what is the the integration points, the frame and those the glass or different compartments, the boxes and everything. Nothing to do with your or the motor yet. I'm able to fix them. Now comes all three together. The motor, when I'm switching on, is my motor starting, kicks in, and is it cooling the whole compartments inside? So what actually happened now? When it is cooling the whole frame inside, that means that includes your glass, your boxes, all different sections within the fridge. What you have done, you've integrated all three together, and you're actually testing for its workability or usability, right?
Yes, sir.
So that is nothing but the integration testing. You have come up with bottom up method, hybrid testing method, incremental approach, stubs, drivers, top down approach. It's a different type of the integration testings. Okay, it's let me give an example, very a simple example on the bottom up method. Okay, so there is a rocket. What do you do? Every single phase of that particular rocket or compartments of the rocket have manufactured one by one. First portion, second portion, third portion, and everything. You have a you're not actually building as a whole in one go. So we are actually doing one by one. Okay, and then you are building the whole thing as a unit, and then you're actually launching the rocket. Now, what is top-down approach? I'll say, rather than building the compartments within the rocket, what I do is I build the whole structure first. I see from the the top view. Okay, I build the whole structure. Then I'll manufacture the engine or the payload and everything. So what has actually happened here? You're first building the structure, and then you're actually building within that internally. Are you with me?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
So it's a very simple methodology is there. Okay, we did discuss about the deployment. or nothing, nothing but like usage, any software into production, like your WhatsApp on your mobile, and then maintenance. Okay, we did discuss about the advantages here. We go phase by phase. Without the completion of a particular phase, you can't move on to the next phase. So that would save a lot of time and any sort of a deviations later point of time, right?
Yes, sir.
So now, it's beautiful here. They've put in advantages and disadvantages. What did I say? Like, emphasizes structured organization. That means you have a definitive structure, requirements, design, development, testing, deployment, and everything, right? You have a structure. And if any, changes can be implemented in early design stages. What does it mean? Any changes to your requirements, you can address them before you getting into the design. So you have an opportunity to go back and revisit and see, like, any changes required. So you have an opportunity to deal with all those changes upfront. Okay, and suitable for deadline and milestone oriented teams. What does it mean? So you define the specific timeline for completion of the finalizing the requirements, finalizing the the design, finalizing the development and everything. So you have specific deadlines. Okay, and also it gives you accurate cost estimation. What does it mean? Like, I need n number of people for designing. I know I need a number of people for development or manufacturing. I need a number of people for the maintenance. I need a number of people for testing and everything, right? So when you know the resources, what is the time it would take to complete those particular phases. So that means you are actually able to, get the estimated, cost. So what do you mean? Let's come back to the disadvantages. It is extremely restrictive. What does it mean? Until you finish that particular phase, you'll not be able to move to the next phase. That means you are restricted. Okay, you can't move to any next stages before you conclude on one particular phase. It can be requirements, it can be design, or it can be anything. Excludes user clients from the process. It's like debatable. Okay, but what does it mean is, like, when you're finalizing the requirements, that is the end client altogether. So their goal is provide the requirements. That's it. They will not be involved in any sort of any other process, like designing, development, and all those things. What they wanted is the product which they wanted. For an example, we need a fridge which has 180 liter capacity. That is what my requirement is. I need a purple color fridge outside. That is my requirement. But you are not involved in any sort of a designing. You're not actually involved in manufacturing. Nothing. Right? And what do you mean by delay testing? So delay testing is nothing. Very simple. Okay. So till we actually manufacture that particular product or a software, you will not be in a position to test it. There are different other models, the software development models. There are iterative models, spiral models, and everything. Okay, which will have a different concept. You can test it in parallel while actually being developed. We're not touching on those models at the moment. Let's concentrate only on the waterfall model. So what does it mean? What do they say? Like, restrictive, the testing. So till you manufacture it, you will not be able to test that particular product. So it's same thing what we discussed. You cannot move to the different phases till you complete or finalize this, the earlier phases. That's it. Am I clear?
Yes, sir.
Yes,
Yeah.
sir.
Yes, sir.
Yes, sir.
Yeah, this is all about the our waterfall model for the software development. Okay, you did we did cover the integration aspects as well, right? Okay, where you bring in different components, manufactured separately or developed separately, and then you're bringing them together, test one at a time or integrate one by one, and then combine all of them together and test it as a whole system. Okay, now comes, since we are actually covering the um, waterfall methodology. Okay, let's touch base upon now the testing side. Okay, could you please tell me, okay, we did discuss in the past beginning of our sessions as well, earlier sessions. Can anyone tell me what is software testing or testing? We did discuss even in today's session too. Why do we need to do testing? What is the significance of testing? How does it add the value to the process?
Verify that a software product or application does not what is supposed.
Can you repeat that for me, please, if you don't mind?
Verify
No,
that
you
a
were right. Can you
software
repeat that
product
again? Uh-huh.
verify that a software product or application does what is supposed to do.
Okay, very good. That's correct.
Whether it's working as per the client requirement or not.
Okay, great. Any more?
Working without any bugs.
Working without any bugs.
Functionality of a software program.
Reduce development cost and improve performance.
We are checking the performance.
No. Performance, one of the factor, like which we discussed, that line it comes under non-functional one. To verify, simple, to verify the given the requirement or a client's requirement or any requirement is the software which has been developed or a product which has been developed is in line with the customer requirements, and it is working as expected with minimal issues or defects. Okay, or that is what you're actually going to verify as part of the testing. Okay, so now how do you test when we are talking about testing? How do you test? Let's take an example of our fridge. Can anyone give me somebody please give me requirements, and other person can give me how you're going to test it.
Response to cold.
Let's go for a requirement.
It has to
Size
have a door.
Size of the fridge.
Size of the fridge is
Freezing.
what?
Freezing.
Requirements.
Okay, one is size of the size of the fridge. One is freezing. Okay, what else?
Color.
Color. Yeah.
Design.
Design. Good.
Single door or double door fridge?
Okay, very good. Single door or double door. Yeah, these are the requirements. Yes.
And the lights.
Lights. Okay, that is also a requirement. Yeah.
Plate should be proper.
The food should
Sorry?
store for a long time.
Plate
It
should be
shouldn't get
proper.
spoiled.
I'm sorry, what is proper?
Plates.
Plates. Okay. Fine. Yeah. Sorry, somebody was saying, something.
Cooling.
Cooling. Okay. Okay. So we got a sufficient requirements now. Okay. Let's take an example of cooling. How do you test?
Comparing it with the room temperature.
Sorry?
Comparing it with the room temperature.
Sorry, your voice is
Amount of freeze off.
Could you
Comparing it
could you
with the
please repeat again?
room temperature.
Room temperature.
Comparing it with room temperature.
Compare with the room temperature. Okay.
Yeah. How much it has been cooled before and after place with by comparing it with the room temperature. Like this.
Can you still see my screen?
Yes, sir.
Yes, sir.
A blank screen?
Yes, sir.
No, sir.
Okay.
No.
No, sir.
No, sir.
Okay. Give me a minute.
Yes, no.
Okay. We talked about requirements, right?
Yes, sir.
Now you are able to see my screen. Okay. So somebody said cooling. Somebody said size, plates, lights. Okay. Sorry if I missed something.
Colors.
Color. Okay.
Double door, single door.
Single door or double door?
Yeah. Door configurations. Yeah.
Temperature control. Automatic temperature control.
Okay. Does it come under your cooling? Okay. Anything else? Let's go ahead with this only. Okay. So these are the requirements, right? For every single requirement, we need to make sure it is working as expected. Correct?
Yes.
Now,
Yes, sir.
let's take an example of cooling. Okay. So let's say test scenario, or scenarios we call it as. Okay. So cooling is the main thing, right?
Yes, sir.
Yes, sir.
Below that, okay, what do you mean by cooling? Is it, look, there are two things, right? One is compartment cooling and freezer, right?
Yes, sir. Freezer cooling.
Yes, sir.
Yes, sir.
So now we know now there are two things as part of the cooling. I need to test two of them. This is my scenario, right?
Yes, sir.
Now out of this, now I'll copy the same thing now, okay? Now under this, we have a cooling, we have a compartment cooling and freezer. So how do I test this compartment cooling?
We need to switch power on.
Very good. Power on. What else?
For
Set
5
the,
minutes. Wait for 5 minutes.
set the temperature
Temperature.
for, minus 20 degree, whatever it is. Okay.
Maximum.
It should constantly run.
Okay. Let the fridge, you're right. Okay. Fridge run for X, X hours. Correct.
Yes, sir.
It should
Now
not leak.
check if the compartment
Cooling.
temperature is now minus 20 degree. How do you test this? Whether the temperature is minus 20 degrees or not? How do you test this?
We keep a temperature gauge, thermometer.
Temperature gauge, or in case if you're as a manufacturer, you have your thermometer, right?
Yes, it will be.
Okay, and then you put the thermometer and you run for X number of hours and will check whether it is now the temperature is set to minus 20 degrees, right?
Yes, sir.
Likewise, freezer. Same thing repeats, and it can be minus 50 degree the temperature, and just check whether it is not impacting the freezer temperature is not impacting your compartment as well.
Oh, yes, sir.
Correct. That is
Yes,
one
sir.
other scenario, right?
Yes, sir.
Another
Yes, sir.
confirmation. Okay.
Okay,
So
sir.
what I want you guys to do now. So now you have seen, we defined the requirements. We also defined scenarios. What the scenarios I can come up with to in order to qualify the any product or software.
Okay.
And then also what we did was we took that scenario and then we broken down into minute steps to test whether that particular given component or anything for that matter is actually working as expected. Okay.
Okay, sir.
What I want you guys to do now, you pick up anything as we did earlier. Okay. You pick up any device or you pick up any software, you could pick up any Facebook, Google, anything for that matter, in and around of yours, whatever you see on a daily basis. Pick up, you define certain requirements, you come up with the requirements and come up with the test scenarios and then come up with the test steps to verify. Okay, let me do it as test steps for every single test scenario.
Okay, sir.
Okay. I want you guys to come up with this for our next class.
Okay, sir.
Okay, sir.
Okay,
Okay.
sir. Okay,
Do
sir.
you have any doubts before we conclude? Okay, today's meeting. Let me know. I'm happy to answer those queries because it's a very key thing now. We are getting into a testing, side now. It's a very, very key thing for you guys to understand.
Sir, in test steps, we can write open door first, like that.
Absolutely, yes. Absolutely, yeah. You come up with your test steps. Yeah, that's a very good example. Yes, you can. You're giving a logical flow to test the whole process or whole thing. Absolutely fine. That's correct. What you did, power on. Yeah, I agree with you. Like, no, we missed some couple of them here. Power on. Put put the plug into the socket, turn it on, then open the door, set the temperature. Okay, close the door, leave the door, leave the fridge for operating for X number of hours, whatever you define the the number of hours, and then go back and check whether the temperature is set to 20 degrees or not,
Yes, sir.
or is actually 20 degree in the compartment.
Okay, sir.
Okay,
Okay, sir. Thank you.
great. Any other questions? Yeah, if no other questions, let's conclude. And once again, thank you very much for joining. And yeah, let's connect next week. And I look forward for receiving your work. Thank you, guys. Take
Thank
care.
you so much, sir.
Thank you, sir.
Thank you.
Thank you.
All
Thank
right,
you, sir.
Thank you, sir.
bye-bye.